Thank you everyone for joining, and thank you Catherine for accepting to present. So Catherine is Director of Research in ISIR, the Robotics Institute in Sorbonne University, and she's specialist of social interactions with robots and virtual agents. And so that's what we have today. So the stage is yours. Vas-y, venez. Ah, vous avez une minute? Non, ok.
Je fais en anglais ou en français? En anglais, in English. Okay. So, hi, thanks everyone. So I've been working on virtual agent. Before it was talking heads and body conversational agent, and lately we call them social interactive agent because we focus on different aspects. At the beginning, it was mainly at least have a face and have and communicate. After we managed to also model this communicative gestures, so have a body, so and body conversational agent, and lately they're also interactive to conversation. So we put the emphasis on social interactive agents. Okay. And as we all know, in the communication, we've learned quite a lot. We can infer quite a lot from just looking at multimodal signals and looking at the gaze directions and also the facial expression, the position towards the other orientation and all that. And that we're going to infer information on the relationship between those two characters, for example, those two silhouettes, but also what they want to display, what they want to express. And what is quite important is that we can go from the cues that are emitted by the one interlocutors and the other interlocutors with infer different intention, different communicative function, different emotional states and things like that. And in our work, it's what we're trying to do is that we're trying to model the agent's cues in order for the humans to infer different function, different higher level function. All right. And in particular, we know that there's quite a lot of social effect linked with the agent, that the agent can display a simple smile or frown, and this social cues, those cues, not social, those cues will infer the humans will infer some information. We are currently, this morning I was discussing with colleagues, we're looking at the impact on a smile or a frown on moral values that particular interlocutors will have, but I'm not going to present that. And so that is something that we're looking at and we're focusing on, and we're going to models. And after so a lot of studies have shown that through their nonverbal behaviors, those virtual agents will influence the perception of trust and cooperation in humans, and will act as facilitators, social facilitators, and also sometimes in increased performance. So here I'm going to present two books looking at adaptation in an interaction. So I'm going to focus on this part. And what is quite important is that when we model interaction, and you look again at human interaction, you found that it's not just talkie-walkie, one talks and the other one is not doing anything. There's this loop happening all the time between the two interlocutors, and we often talk about dancing, joint actions, and there's a lot of synchronization happening between the two interlocutors. All right, and we want to model this dynamic coupling between the interactant. Okay, so what we found, and that this coordination of cues is found in many different activities. It can be found in dancing, in musician groups, and as well as in communication. Okay, and this coordination is crucial because at the same time it shows the quality of a group doing different activities, but it also allows you to anticipate, to predict the partner's action. Because if you want to be synchronized, you have to anticipate how the other is doing in order to fit your behaviors. Okay, so that's why we're going to focus on one aspect, which is naming adaptation. Okay, adaptations occurs at many different levels. We found that there's adaptation that occurs at the level of simply showing back channels, some showing that you're understanding, you're there, and there's a lot of imitation. For example, I smile, you smile back, and those is not shown of emotional cues, but I mean it just point as imitation. You have also postures imitation. You have quite a lot of imitation there, and also a lot on the verbal alignment. Choosing a certain vocabulary or a certain degree of formality or informalities and things like that. So, and there's different level of synchronization also. And those cues will also infer some information about the quality of the interaction. Like it will show signals, interpersonal relationship in signals, also of rapport. It will help to establish trust and favor engagement and things like that. And there's one particular, there's a lot of different theory that look at adaptation. And one that we looked in particular is work by Burgun on expectation violation theory, which look at the social expectation of interlocutors. So you have the negative expectation, where it's where the behaviors that are emitted by one interlocutors will be contrary to the expectation by the other interlocutors. Okay, so they will have somehow, they will negatively violate interlocutors' expectation. And on the opposite, you have the positive expectations that are behaviors that positively violate interlocutor expectation, somehow are coherent with the expectation. Okay, and what has been found is that rapport between humans, between two humans, will increase with positive expectation. That means there's this coherency, this positive coherency in the behaviors of both interlocutors. Okay, so we're going to focus on those aspects and take that as a basis for our models. So lately we had two projects with Japanese partners. The TAPAS project, which was a French, the INR GST CREST project. And there, so we have the different partners, Satoshi Nakamura groups, Nara Medical University, Osaka Universities, and ourselves, and Jean-Claude Martin from the LISTEN Paris-Saclay. And the aim of the project was to model systems that can serve as support for CBT, cognitive behavior therapy, and social signal therapy. Okay, and so what we wanted to do is build an agent that is able to adapt to users' social skill profile. So for this work, we developed models, an adaptation models, where we look at two aspects: intrapersonal synchronization. When we talk, our body gestures, our arm gestures, facial expression, head movement, and prosody are highly synchronized. Okay, so we wanted to take that into account. So this intrapersonal synchronization, and also we wanted to take into account the interpersonal synchronization. That means the behavior coordination between the two interlocutors. So we want to have a model and adaptation models that look at those two synchronization mechanisms, not only just pure imitation with the others. Okay, and we call it this reciprocal adaptation, which will be continuous, reciprocal, and dynamic adaptation of verbal and nonverbal behaviors. And here we're going to focus on nonverbal behaviors. And the hypothesis was this reciprocal adaptation will enhance the perception of the virtual agent, always at the quality of the interaction. So the way we've done is quite classic. It's first we analyzed human behaviors, then we built a model from this analysis, and we predict the agent's behavior from the user's behaviors, and after we evaluate it through a given application. So we started by looking at one corpus that we had gathered a long time ago, the Noxy corpus, where it was two humans facing each other's, and they're not face to face, but they're on facing through a large screen. So they have human size on both sides, and you have at the same times kinect, and we can analyze facial expression, body movement, prosody, and verbal alignment, and all that. But in the conversation, we had to have very natural conversation. We ask people to pair by the topic of conversation they were interested in. So one person who says, I want to discuss about, I don't know, video games, photography, whatever, theater, and so that. And the other one who says, oh, I want to learn about those topics. So like that, we had very, very lively interaction between both interlocutors. And so we had this one, and we started, we extracted the facial expression of both interlocutors and the head movement. And after we built the models that captured the intrapersonal relationship between the two interlocutors and also oneself, okay? So for the intrapersonal relationship, we looked at how the evolution of the multimodal signals of one person evolves through times in order to have continuity. And for the interpersonal relationship, maybe it's better if I show it here. So we start with this one. So we have the speech and the facial action unit and head movements, and those get encoded in this intrapersonal encoder. We do the same with the other humans, and after we replace one human with the agent. And after those two encoders are into this interpersonal encoder to capture the relationship between the two interlocutors, okay? And it allows us after to compute the behaviors, to predict the behaviors at the next time frame. So at every frame, we encode the intrapersonal synchronization and the interpersonal synchronization, okay? So that means that at time t, when we want to predict the behavior of the agent, what we do is we take the behavior of the human so far at time t, we take the behavior of the agent at time t, and we use those behaviors that have been displayed so far by both interlocutors, agent and human, to predict the behaviors of the agent at time t+1. So as that, we have a continuity in the behaviors. So the first things we've done is to ensure that our models was doing what we predicted. We're conducting a simple studies where we replace one of the humans in the corpus with the virtual agent. Okay. So let me show you.
D'accord. Exactement, parce que j'ai tellement pris l'habitude de quand écouter, c'est pas juste pour écouter pour suivre, que maintenant, un matin, je me dis, ah tiens, j'ai envie d'écouter.
So we can see that the model is able to capture the agent behaviors when it talks and when they listen. So it has both aspects.
Ah non, non, mais moi, pour bosser, je fais de la musique classique.
D'accord.
Du Chopin ou des trucs comme ça, parce que sinon, non.
Ouais.
Sinon, avec la bondalou, non, je bosse pas du tout.
Tu pars.
C'est mon cerveau, il part ailleurs et ça va pas, non.
Okay.
Non, j'arrive pas à bosser avec ça.
Okay. Là. So, okay, so there we're conducting some objective measure and subjective measures. So we looked at different error measures that you have classically in those deep learning models. And also we looked at this notion of synchronous mind. So let me show you. Should I put it somewhere else? So I come back to it. Synchronous smile. So in the synchronous smile is a very, very important social cue that we use quite a lot, okay, in an interaction. So you, as I said, you often have imitation. I smile, you smile back. But sometimes I smile, you don't smile. Or you smile, I don't smile, okay? So when we looked at this notion of smile, is our model able to capture the different property of this particular social signal, okay? And in particular, what does it mean? You smile, I smile at the same time. In fact, it's never occurred exactly at the same moment. We don't start at the same frame. So we consider different temporal imitation phenomena. So it could be embedded within the smile of a person, or one smile, the other one smile, and the other one smile. Or sometimes there's a delay. And we talk often that within a 4 seconds delay, it is perceived to be as an imitation of a smile, which is from the perception point of view. So several studies have shown this 4 seconds delay as being an imitation of synchronization of smile. Okay. Sorry. Okay. So having done these studies, we moved toward doing a human-agent interaction, and it involved building such an interface, which is quite usual. You have a human to capture the user speech of a mic, and a camera to capture the face. And here, what was really hard is that we had to do this computation frame by frame. We couldn't have 1 frame delay. So that means that we really had to work quite a lot at the engineering level to ensure that we have the behavior. This study was done before ChatGPT. So the dialogue models has been produced by the psychiatrist, the Japanese psychiatrist in Nara behavior. So it's quite scripted. There's different phases that is being developed and that we follow. So the application is for cognitive behavior therapy. And in cognitive behavior therapy, you have different steps that you have to go through. That's why we follow those steps, okay? And one, so that is the step. So this is how it is done, the setup. One particular difficulty is at one point. So in cognitive behavior therapy, particularly, is that you want to models and to you have the person that have a negative thought, okay, is not feeling well, and you want to make the person analyze the event that make him feel bad from another point of view, okay. So that means the systems have to detect this particular negative thought and have to make him reflect on it. So for detecting the negative thought, we use a model that was developed by the Japanese partners. And for us, when you have to reflect on your negative thought, take another perspective. What is happening? You take time. So slow silence. That means that the agent has to respect the silence and do not take the lead, do not take the turn right now. So in fact, most of the times we fight of being too slow. Our system is too slow. We don't, we are much slower than in human-human interaction, but then it was the opposite. We had to slow down to ensure that at these particular moments, the systems won't interrupt and won't continue the conversation, okay? So this is Zhejiang Hu, so I cannot show you the other videos, but so it's
J'ai peur que j'ai fait quelque chose de mal, donc elle me répond pas.
Quelle première pensée très forte vous est venue à ce moment-là?
I forgot to mention that our speech synthesizers, we don't play with it. Cereproc is a commercial one, and we don't play on the parodies. That's why the voice is flat.
Parce que j'ai attendu 6 heures et elle ne me répond toujours pas.
Si elle ne correspond pas à ce qui s'est passé, dites-nous pourquoi.
Okay, so it goes on. Back. Okay, so the architecture is like that. So you have input. It goes. We're using the classic system in our filter: open face and post smile to detect the action unit on the face and head movement, and open smile for the prosody. And those goes into the behavior generator for our model. okay, and using database, but at every frame. And for the ISIR, it goes and looked for to detect through the term taking management and the automatic classifiers to detect what to say next. So it's Flipper is it's a dialogue model that is developed by University of Twente, and it's like a graph structure. So it's really before LLM and after we render the step. If you have any question, you interrupt me, please. Yeah.
The agent was saying no.
Écoute, yeah, I forgot. Right.
Dites-nous, tell us.
Tell us, yeah.
So you're using a plural form for...
Well, I didn't think of that. Yeah.
Okay.
Because I think it was maybe advertised by the Japanese partners. Yeah, that's right. I didn't pay attention. Okay. So what is the focus here is that at every frame we compute the facial expression of the agent, okay, and we ensure to have this continuous display. So as I said, the setup was like that. So the agent is displayed on the back of the person and also in the front because we wanted to capture the human-agent interaction to conduct further study, but we didn't have one. We just had the database. And we done some evaluation. So to do the evaluation, we consider different conditions. The agent driven by our model, okay, the agent showing expressive and adaptive behaviors. Mismatch, that means the agent display the pre-recorded expression from another previous animation. So that means that the agent was showing some expression, some being expressive, but not adaptive, not synchronized with what the human is saying. Okay, it comes from another direction. And still pose, the agent just moving the lips, because it's what a condition that was our Japanese partners had in their study. Okay, so we had 3 conditions where here is agent shows expressive and synchronized behaviors. Mismatch is expressive and non-synchronized. Here is non-synchronized, non-expressive, and also there is no problem of synchronization here. Okay, and the hypothesis that our models, the agent showing expressive and synchronized behaviors will be positively better perceived, and we have an effect on the cognitive behavior therapy more than on the mismatched behavior, as well as the still position. Regarding the objective measures, we looked at the smile that has introduced before, and we look at those different error measures. So it's look at the resemblance of the agent's behaviors and user's behaviors using DTWV or Kolmogorov test to check the similarity distribution between the agent behavior and the real human's behaviors. Okay, those are common behaviors. And the subjective measures, we ask several questions regarding the agent's perception. So on the level of naturalness, human likeness, synchrony, engagement, and rapport. And we ask also different questionnaires regarding CBT. So for the mood, the level of anxiety, distress, and cognitive states. And what we found, and that was quite surprising to us, is that our models did perform better than the mismatch, which was good, and did perform better than still pose. However, participants disliked more the mismatch versus the still pose. So they preferred interacting with the agent that showed nothing at all, rather than the agent that shows behaviors but were not synchronized with them. They perceived it. Okay, that was really very interesting for us, and we found it in another study. Okay, so this notion of very subtle cues, because it was just facial expression and some head movements, are really important to be in sync with your interlocutors. Okay, and we also had some effect regarding the CBT. So that was one model. So I'm going to talk about this other project, and where we looked again is panorama, and there is a French, Japanese, German project where the partners were Seagate University and JAST, University of Oxford, and after again Jean-Claude Martin, Paris-Saclay, and ourselves. Okay, so here we wanted to look again at adaptation mechanism, and we looked also at verbal adaptation. For there, it was something similar to CBT, but we focus more on motivational interviews because we have no more psychiatrists in the project, in the partners, and it was a bit safer to work with motivational interviews. Motivational interviews is a techniques for to help people that want to change behaviors, stop smoking, do sport, eat better, and things like that. Okay, and so it's a way of as an interaction where you focus on the goal of the person of your. Sometimes it's called patient, sometimes it's called clients in the literatures, and you really adapt to the user's willingness to change. Okay, is it ready to change or not ready to change? Okay, so we looked at different theory, and we in particular look at self-determination theory and rapport estimation to ensure to enhance users' motivation to change behaviors. Okay, so looking more on the motivation interview, so it's help to facilitate person to change behaviors. It relies on intrinsic motivation, so the motivation to change has to come from the person itself. Okay, and you use different therapists use different dialogic strategies and through nonverbal behaviors. And in interviews, you have different phases. You engage your interlocutors, then you focus on the topic, on that, then you evoke some possibility how you can change behaviors, and you plan how that can be done. So you have those different phases. So to conduct our study, we go back to a database, and this time we refer at a database you can find on the web. There's two databases called Anomi and Mid Corpora that are available. They're not genuine interaction because again, there's the notion of privacy. You cannot. So it's actors in both sides, but it's to train therapists. So you have sometimes good therapies, bad therapy, and so just to show the next future therapist on what is a good interview, what is a bad interviews. Things like that. So in our study, we looked only at the good therapies, those were labeled good therapy. So we had like 285 videos, 20 hours recordings, and they were annotated with an annotation schema called MISC. MISC is related to dialogue act. So it can have for the counselor or the therapist and the patient different dialogue act. What is quite interesting for the patient, for example, you have what they call neutral. It's more talk on or giving information, things like that. Change is anything that the patient is saying related to willingness to change behaviors, and sustain is anything related to resistant to change. So anything that the agent, the client will be saying will be characterized along those three dialogue acts. Okay, neutral, change, sustain. For the counselors, these questions, reflection, and input. So those are very, very high level dialogue act. Okay, it's not a classical dialogue act, performative dialogue act, like that. And having those database, we're conducting different studies. So we looked at the nonverbal behaviors analysis, and we studied the co-occurrence of action unit between both interactant. Okay, for example, if the therapist is speaking, what is the behaviors of the client? of the patients is a client or patient is speaking, what is the behaviors of the therapist? And after, if the therapist smile, what is the propensity of the client to smile back and vice versa? Okay, so we have different aspects on the behaviors of each interlocutor and how they interact with each other. And also we look at the propensity of the different behaviors along the interaction. And we found in particular that the therapist smiles much better, much more at the beginning of the interaction, where they really want to create a relationship with the client, than toward the end. So he put a lot of emphasis on creating a relationship with his patients. And once it is established, he doesn't have to smile so much more, because that is being established. So those were quite interesting for us to model the virtual agent. Yeah.
I have a question about what you define as an interaction, because I see the scale seems to go to like 80 seconds, which is maybe like you're talking about one specific topic or in the down. I was able to zoom on my screen.
Yeah.
But so one interaction is like one dialogue act.
No. No. That is for it's more towards the whole interaction.
Okay.
So I guess it's an error of this.
Okay, so we go.
No. It's 5% the whole interaction.
Okay, thanks.
So it's often between 15-20 minutes long, if I'm not wrong.
Okay.
Yeah. And we conducted similar analysis at the verbal level. And what we found is that there's different types of patients, and that can be clustered as patients that are ready to change. And for those patients, you can see that they're doing less sustained talk at the beginning for the first half and the second half of the interaction. So it's really divided for the whole interaction. Okay. So for the whole interaction, we can see that there are differences for the type of behaviors. Okay. That is the proportion of change talk, but we have something similar for sustained and neutral. While resistant to change, they start and end with less change talk. They really are not ready to change. Receptive, they start with less change talk, but at the end, they display more change talk. Okay, so we can see that for the receptive, through that verbal dialogue act, they're toward the end of the interaction, they show propensity to accept to change talk, change behaviors. While ready to change, they right away have ready to have more change talk. Okay. And after when we have that, we can look as a therapist, what is the different strategy that the therapists are conducting towards in front of the different patient types. And so globally, the therapists, first, because we have different phases, first they ask a lot of questions about the context and about the patient concern. So it's really engaged and focused on those two aspects. Then it plans and advises. And there is okay. And what we found is that for participants that are resistant to change, it's going to use much more empathic statements than for the other type of clients. But for the receptives, it tries to make them change perspective, take another perspective to understand their need to change behaviors. Okay. While ready to change, is looking more at the intention to change. So the therapists take into account that they're facing different user types and adapt their non-verbal and verbal strategy.
And just reciprocally, the clusters, they are not correlated with the therapist. Like it's all good therapists. It's not like one therapist has many resistant to change because it doesn't manage to, I don't know.
Because it's difficult to answer because the database is really it's done by actors. Okay. So I don't know if it's in real life it has an impact. Okay. I have no idea. I cannot say.
Okay.
We use this database. We could have access to a database for real therapy, but we had only, because of privacy, we had only the dialogue with the text. And in our lab, we focus a lot on nonverbal behavior. So we said, okay, it won't help us to have only the text.
Okay.
Yeah, that's why.
Oh, sorry. So from the beginning, you ask people to have one of the behaviors.
No, in fact, it's a database you can find on the web.
Yeah.
And it's where you have. I don't think we've done a study. It's because we took only what they call a good therapist.
Yeah.
Those were labeled a good therapist.
Okay. No, I was just wondering if there are actors, what instructions the actors had.
I had no idea. We have the girls. We have no information.
Okay.
Yeah.
Because maybe the clusters were related to actor guidance.
It could be, I guess, because I guess the actors were.
And so who's been told something, like was the patient told to be receptive to change, or was the therapist told to induce? I don't know. It's a
Depends on how the database was done, and I have no clue. I don't have information on the instruction that was given to the actors.
No, just for you.
Yeah, it's true, but yeah. I have no idea. So we built two models, one for the facial expression generator and one for the verbal, the dialogue act. Those are two different PhDs. And for the facial expression, we used it's work by Nezi Yunsi, just defended this PhD, and he used diffusion models that works in real time. So it take into account the facial expression that was done so far. It take into account the dialogue act from the therapist if the agent is speaker or listeners, to compute the nonverbal behaviors of the agent. Okay. Regarding the dialogue models, it's using reinforcement learning for adaptation mechanisms, and it predicts the next dialogue act based on the user types. So that was here determined in our study, in our evaluation study I'm going to present in a minute, through a questionnaires before the interaction. So we don't detect the type of users in real time. Okay. And also the different interview phase that is computing automatically. Okay, so we take into account what the user is saying, playing a patient, and after it goes, it extracts the dialogue act, so change, sustain, or neutral, and it's sent to the dialogue managers that, depending on the user types and also the different phase of the interaction, in which phase it is, it computes the next dialogue act, virtual therapist, and after using an LLM with different prompt, it computes what the agent should say, and that is sent to the virtual agent. Okay. So this is the interface, but what is important is that we have a humans here, and we compute in real time the dialogue act and the facial expression of the agent. And at one point, we wanted to study the impact of physical presence. So we display the virtual agent onto Ferhat, which is a robotic head that have a translucent mask, and you can project a virtual agent. So we had the same display, but on the screen and on the agent. So let me show you two examples. So that was done in the lab, this one.
Quel moment de la journée pourriez-vous utiliser pour ajouter un peu d'activité physique?
Sur le temps de la pause déjeuner, peut-être?
C'est une excellente idée. Que pourriez-vous faire pendant cette pause déjeuner pour être plus actif?
Je travaille sur un campus universitaire, donc il y a un certain nombre de sports accessibles par les associations étudiantes.
Parfait. Quel sport vous intéresse le plus sur ce campus?
Je ne connais pas.
And here we're just conducting a study that was done at INSEAD. INSEAD, it's at Sorbonne University. It allows us to do evaluation study with naive participants, not your students or not students in the lab. They have a pool of participants that they can call. So here is an example.
En faisant un programme et en établissant une organisation un peu plus structurée à l'avance.
Merci pour votre ouverture. Il semble que vous avez dû une bonne compréhension de ce que cela pourrait signifier pour vous d'être plus actif. Vous avez mentionné que vous ressentiriez plus d'énergie et une meilleure santé. C'est un excellent point de départ. Comment vous sentez-vous en ce moment en discutant de cette possibilité?
Rien de spécial parce que je sais que c'est pas facile à mettre en place, donc voilà.
Okay.
Quel moment de...
Now, so again, we're conducting different study. So here I'm going to present this study that was done for the facial expression because 2 PhD students, they're quite aligned. So their work is 100% integrated within each other's, but conducting first this study that I'm presenting. And you see the last video, she's just finished up. So, and she's graduating in this in the fall now. So again, he conducting 3 for the facial expression, he conducting 3 conditions. The model, so expression synchronized, mismatch, expressive but not synchronized, and still not expressive. Okay. And we had 60 participants, and we had different objective measures. Here we looked at also how much information do each participants disclose. Okay, and the idea was that if you feel okay in the interaction, if you build this relationship with the virtual agent, you will disclose more, okay, and have more sentimentality and things like that. And at the same time, we use different questionnaires, perceived attitude and coherence, social rapport, and motivation interviews, and social presence for the robot. Okay, and what we found is that the this is in blue is our model, in orange mismatch, and in green control. That there's a shift of the disclosure with the length of towards the interaction times. For the compound sentiments, there's much more for the mothers, and as the same for sentimentality. Okay, and for the subjective measures, we didn't find significant differences between the model and the control, but we did find differences with the mismatch conditions. So, as a conclusion, I presented some work on adaptation mechanisms linked to expressivity, congruency, and synchronization. And some studies, our study shows that it has an impact on engagement, rapport, and interaction quality, not always statistically differences, but has an impact. And what we can find that if you violate participant expectation, like for example, in the mismatch condition, that will have an impact on the perception of the agent and on the quality of the interactions. So somehow it aligns with Bergen's models of expectation violations theory. And we're looking at different aspects. A lot of, all the studies I've been showing and all the studies we're conducting so far is on the addict interaction, but a lot of our interactions multi-party. So how can we go from the addict to multi-party interaction? And we have to change completely our models, turn-taking mechanisms, who is the speaker, something like that. So it changed a lot. The way we're conducting adaptation, the social context is extremely simple. It's just a person in front of you. That's it. Okay. And we need to look at more modality. We're working quite a lot on social touch and also on laughter. laughter is a very, very important mechanisms. We're looking also on social repair, on if your interlocutors interrupt or ask for what have you said? What do you say? Why? And things like that. And we're looking also at some ethical concern, in particular, notion of attachment that you can have, that can be triggered by this virtual agent. Okay, so that's end my talk.
Questions?
Yeah, I have one question. In general, it's about the adaptation. Is it a parameter that you can change? Like you want the agent to adapt, or you want the human to adapt to the agent? It's in this way. It's a bit general, but
so it's difficult to ask a human to adapt to the agent. But one thing that, for example, here is you want the agent to adapt continuously to the humans, and you don't always adapt. You don't always enforce engagement all the time, for example. You don't want always to increase rapport. During an interaction, it will fluctuate. Okay, those. And that we don't model it. Each time the agent has a goal to adapt.
Okay.
And that, I think we need to model more on a higher level when the agent should adapt and when it should do it less and things like that. I mean, but we have to look at other phenomena. The pure engagement and things like that, yeah.
Like the dynamics you describe of engagement, increasing, fluctuating, is this studied in some way?
So from what I know, a bit less, because it's in human studies, we looked at what are the phenomena involved in being engaged, and so far in our agent, it was quite hard to already engage. But now that there's quite a lot of different models, not our work, but other models that start to work. It's time to really when you should adapt and when you should not, and things like that. And it could be also linked to some ethical concern. I mean, so you see, you create too much attachment, maybe, or you question ourselves how the agent should behave.
Because in the videos that you were saying in the data sets, therapists smile a lot at the beginning to create contact. So it's sort of they try to adapt their patient to they try to influence something on their patient, or like motivational talk is you try to influence.
Yeah.
So it's rather also trying to see how the human will adapt to the.
Yeah, but it's must admit, if you see in those two models, it's 100% machine learning, and it's based only on dialogue, on non-verbal cues. Okay, no information, no model on the underlying intention, perceived intention of the humans, underlying perceived beliefs or goals, nothing. So it's a bit dumb. I mean, it's. I found it. I mean, I really like the work of this work. I mean, I'm very proud of the student what they've done, but there's no decision models, nothing, and it's what is missing a lot. I really think if we want to get further down, yeah.
But also on the ethical side, I think there is a law passed recently that you can't. It's forbidden to detect emotions from facial cues or stuff like that. So could be really.
So that is different because we don't use, for example, the emotion. We use just the cues. We don't interpret.
Yeah, but if you detect smile, you detect emotion some way.
We detect only smile can have
emotionless.
Everything. It doesn't have to be only. It can be a polite smile. It can be a aggressive style. Yeah.
Yes, but what I mean is, would these virtual agents really be usable in?
First of all, I mean, I really think this notion of ethical concern should be raised when you build such an application, and that's something we didn't take into account. So I really think if you want to make it out, you have to take that into account.
Yeah.
I mean, really, it's absolutely, and understanding the impact. Because in the studies that we've done, first of all, I mean, participants that accept to be part of an interaction, but they were not so much inclined of changing behaviors. You know, they come to a study, but they don't know what it is about. They know it's going to be about the virtual agent, but they don't have the incentive to change behaviors. So already it's fake. I mean, it's start from that. And I really think if you want to go for an application, you really, really, really have to take into account the impact of the non-verbal behavior and the verbal behavior of your agent on the humans, how it will have impact. Yeah, and that we don't take that into account. We built the models, we study how the models is done, so that we can understand the impact, for example, that synchronization of behaviors have on the humans. I was not expecting that participants would prefer still position rather than mismatch. My hypothesis was the opposite way. It's better to show some movement than nothing. So understanding that, measuring that has an impact is quite important after. So we're really under 100% research. Doesn't mean that we have to delude any ethical concern. Absolutely bad. Yes, it's yeah.
And to go further in this direction, because there's a lot of articles about people using ChatGPT as therapy. And so it goes a bit in this direction, like the fact that you can be emotionless, it doesn't.
Sometimes I think it's one thing which is what you find out is that users attribute to the agent based on their behaviors. They attribute different competencies or different emotions, different empathy. So you have to take that into account, and so that the humans' attribution of the agent's behaviors, they extrapolate some information from the user's behaviors. That's why, for example, I believe it's not my study that people will attribute that ChatGPT is a good therapist that is caring about their needs and problems.
Okay.
As they extrapolate their attributes. I mean, in fact, I didn't show, but we had one video where we had in one of the study which I showed, that was just done at INSEAD, the agent, the ASR, understood badly. The participants mentioned she's going to the salle de musculation to do for sport, and she understood isolation. Okay. And after that, dialogue went perfectly well. I mean, really. And she used salle d'isolation and the salle de musculation because she doesn't understand the word. I mean, really. And but the participants didn't look puzzled. What do you mean? Maybe she found the words interaction weird, so she said one word more or something like that. But yeah, it's just this notion. Yeah, I think it's quite difficult, and how the agent should behave. And saying to stop this notion of is a therapist or not.
And was there a difference between the physical with projection on the face?
So in fact, people, the notion of presence is quite important. People prefer it has more impact because it's physically there, and the head movement is quite nice and things like that. Yeah, it had an impact, and this is also. So if you have a robot, it's physically there. So and an agent, but that is something after. If you continue this notion of if you want to do it as a product, it's true. If it's a robot, often Guy Laban had the same found the same result that it's in somehow it's more public space because it's there. If it is on the screen, you can have it on your mobile. and you can have a private conversation, more private conversation. And if it is, so you may have different concern also towards a robot or virtual agent, but it's true. Most of the time people feel more engaged with a physical presence and with an agent. Yeah.
And you also mentioned cultural differences between France and Japan. Can you comment on that?
We did have the time, the project ended before we did, because in fact we had, we imported, so the Japanese models for negative thought detection onto our platforms, and we imported our model onto their platforms, but after project ended and everybody left, so we couldn't conduct the study. Yeah, so we cannot say more on cultural differences on that. So it was a pity. But after, sometimes it's a bit difficult, especially in Japan. They have a view of robots and virtual agents quite different from what is in France. So that may have also an impact on the perception of those tools.
Yeah.
But I cannot say more on that. Yeah.
Okay. Any more questions? No? So I think it's good to close there. Thanks again, Catherine.
J'ai une question slide 29, j'ai oublié ce que c'était.
De quoi?
J'ai une question slide 29, j'ai oublié ce que c'était.
Ah, ok. Attends, je peux programmer ça.
Après.
Là, comment je fais ça? Donc on va mettre ce partage d'écran là. Ah, voilà.